Welcome to the Explainer. Okay, let's dive right into this because there is a profound evolutionary shift happening literally right now in the architecture of artificial intelligence. For the last few years, we've been absolutely captivated, right? We've seen AI generate text, write complex code, and mimic human reasoning in ways that feel like magic. But here's the thing. There is a massive, fundamental difference between imitating intelligence and actually possessing it. So today, we're going to explore how the next generation of AI is moving way beyond simply predicting human data to actually experiencing the world, pursuing real goals, and operating under what is known as the energetic paradigm.
It's the question on everyone's mind. And honestly, the explosive rise of large language models has created this powerful but ultimately kind of misleading intuition. We naturally tend to think that if a system can reproduce the language of intelligent beings, fluently explaining scientific theories or drafting up complex plans, well, it must possess the underlying cognitive structure that produced that language in the first place, right? But this is an illusion. What we're doing is confusing the mere traces of intelligence with the actual working mechanisms of intelligence.
Which brings us to stage one, the limits of imitation.
To really grasp the limits of imitation, we have to look closely at the data these models actually train on. Human text is the output of beings who already perceive the world, who act, and who suffer real consequences. A language model, on the other hand, just learns the statistical regularities in that text. It's essentially playing an incredibly sophisticated giant game of next token prediction in a symbolic stream. It doesn't actually select or evaluate real physical interventions in a causal world. It's just guessing the next word.
In a system built entirely on imitation, it's pretty straightforward. An AI ingests vast amounts of human knowledge, extracts the underlying patterns, and then uses those patterns to make a prediction. The entire paradigm is governed by one single core question. What pattern should I reproduce based on previous examples? It's a completely closed loop of human imitation. The system gets to observe the polished results of our thinking, but it completely misses out on the actual messy process of encountering obstacles, making hard decisions, and adapting to reality.
So, how do we break out of that closed loop? That takes us to stage two, learning through experience. To move beyond mere imitation, we have to step outside the digital library and step into what AI pioneer Richard Sutton calls the experience era. So the crucial point is this concept of operational ground truth. Let's say an agent takes an action expecting result A, but the real world slaps back with result B. That mismatch right there? That is corrective evidence. The system is quite literally surprised by reality, and it has to reorganize its internal models based on that surprise. An AI that only generates what a person might say about a surprise can describe it, sure, but it isn't actually corrected or reorganized by it. True knowledge requires a firm ground to stand on, and that ground is experience.
Under this new experience-based paradigm, the system is governed by a totally new active question. What happens when I actually act? The agent observes a state, takes an action, receives that raw corrective feedback from the world, and then adapts its behavior. It's no longer just predicting text. It's building a continuously revisable expectation of how the physical or digital world actually changes in response to its interventions.
But there's still a missing piece here. Let's look at stage three, the need for goals. Because honestly, experience alone still isn't enough to define true intelligence. If an AI just aimlessly interacts with the world, it's really nothing more than a passive observer taking notes. Think about a weather model for a second. It can perfectly forecast a massive rainstorm, but it doesn't grab an umbrella or try to change the outcome. Without a goal, an AI might be able to perfectly predict what will happen next, but it has absolutely no internal basis for judging whether one outcome is actually better or worse than another. Goals are what give direction to adaptation. They are the spark that transforms passive observation into active, directed intelligence.
What's really fascinating here is that in the real world, a goal is never just a simple numerical target ticking up on a screen. Goals exist inside incredibly strict, messy constraints. If an AI is simply programmed to maximize one single reward, like, say, user engagement or task completion, it might achieve that short-term win while completely destroying essential long-term structures. It might consume irreplaceable resources or violate critical safety boundaries. So true goal-directed intelligence requires a framework that prevents the system from optimizing a quick local victory at the cost of its own survival or integrity.
And that brings us to the core of this entire shift, stage 4, the energetic paradigm.
This is the climax of the explainer, really. The big revelation is that true intelligence organizes experience around energy allocation. Every single choice an intelligent system makes involves spending limited resources. It's not just about blindly maximizing a score. An action might yield a fantastic result, but you have to ask, what if it consumes way too much computational capacity? What if it takes too much time, demands too much attention, or breaches the system's risk tolerance? True intelligence is a highly complex, multidimensional evaluation. It's the ability to decide not just what is technically possible, but what is actually worth pursuing given the limited resources available.
Ultimately, the energetic paradigm forces a system to look at its current state, deeply factor in its goal structure and all those constraints we mentioned, and then decide how to allocate its energy to achieve a new, desired state. The operative question totally shifts away from imitation and moves to consequence. What action best transforms the current reality while preserving my critical constraints?
So what does this look like in practice? Stage 5. Large energy models.
This is where the future of AI is actually heading. The next massive leap isn't simply going to be building slightly larger versions of the language models we have today. Look, scaling imitation might make for a smoother chatbot, but it does not automatically yield autonomous intelligence. Instead, we are looking at a fundamental architectural divide. Large language models, or LLMs, are built for symbolic continuation, basically figuring out what is most likely to be said next based on human data. But large energy models, or LEMs, they are built for consequential state transition, and this brilliantly illustrates the difference. LLMs learn what humans have said, while large energy models become accountable to reality by learning what their actions actually do.
To actually achieve this, the blueprint for the next generation of autonomous AI is demanding. To continually learn and operate in the real world without just losing its mind or overriding its safety limits, an AI must do several things simultaneously. It has to understand its environment, maintain long-term goals across time, strictly manage constraints and allocate resources, and diligently learn from the consequences of its actions. But most importantly, it needs to correct its own behavior through controlled revision. It has to be plastic enough to learn from something new, but conservative enough at its core to maintain its identity and its safety boundaries.
Which leaves us with a pretty profound challenge. As we shift from AI that merely mimics intelligence to AI that develops true energetic intelligence through controlled experience, the stakes become massively real-world. Human control over these systems won't be about predicting every single micro-action an AI might take. It's going to be about engineering incredibly strict constitutional boundaries. Which goals are they allowed to adopt? What costs are they absolutely forbidden to impose? As we grant these systems the agency to transform reality, we have to ask ourselves, are we building the right constraints today to ensure that the autonomous minds of tomorrow remain firmly accountable to us?